All right, today is another new operation with radicals, and today we are going to be dividing. And with this division, we're also going to be rationalizing our denominator when necessary. So on the first six, our goal is just going to be to simplify. And what's a cool little property is that if you have a radical in the top and the bottom of your fraction, like we do in number one, you can rewrite it as one big radical. So radical 125 over radical 5 is actually the same thing as radical 125 over 5. And now when you look at that, you're like, oh, I can simplify 125 over 5, and 125 over 5 is 5. So this becomes the square root of 5. Then check, does 5 have any perfect square factors? Nope. So this right here is your final answer. Same thing on number two. Two radicals on top and bottom can turn into one big radical, so 98 over 2. And 98 over 2 gives you the square root of 49. The square root of 49 can be simplified because it is a perfect square. The square root of 49 is the whole number 7. So number 3 also has a radical on the top and the bottom of your fraction. So in this case, you recognize that 18 over 6 can be simplified. So make it one big radical, becomes radical 18 over 6. 18 divided by 6 gives you 3. And again, that stays under the radical. Then check, does 3 have any perfect square factors? Nope. So we are done. Number 4 is already written with a fraction under the radical, so go ahead and simplify under the radical, and 90 divided by 5 gives you 18, still under the radical. 18 has the perfect square factor of 9, so it breaks down to rad 9 times rad 2, and the square root of 9 is the whole number 3. So you multiply the ends of your branches together, and you get 3 rad 2. Number 5 is already in the form of one big radical, and on the inside of your radical, you can simplify that fraction because 36 over 6 can be simplified. 36 divided by 6 is 6, and it stays x squared. Now check, 6 has no perfect square factors, but x squared can be simplified. Remember, there's a silent little 2 right here, and 2 can go into 2 one time, so 1x comes out. It's even, so there's no variable left underneath, and the 6 stays under the radical. And then number 6, it's a special expression because you have the square root of 81x to the 4th over 100. So 81 over 100 can't be simplified, but when you look at the top and the bottom of your fraction, 81 and 100 are both perfect squares. So we can also go from one big radical to two little radicals. So this becomes the square root of 81x to the 4th over the square root of 100. So we went the opposite way, one big radical to two little radicals. So the square root of 81 is 9. There's a little silent 2 here, so 2 can go into x to the 4th 2 times, so x squared comes out. And the square root of 100 is the whole number 10. And 9 over 10 can't be simplified, so at this point you would stop. So there's just some basic ways to simplify. But if you look at the next 9, you'll notice that all 9 of these problems have a variable in your denominator. And it is not okay to have a variable in your denominator. Just like with our imaginary numbers, we couldn't have an I down below. We had to simplify that. So if we have a variable in our denominator, we have to rationalize your denominator. So a radical up top, totally okay. You just cannot have a radical in your denominator. So you get rid of it by rationalizing, which means that you multiply the numerator and denominator by whatever the radical is in your original denominator. That's a lot of big words, but what it means, to get rid of the radical down below, you multiply by the top and the bottom of the fraction by the radical in your denominator. So on number 7, we have 1 over radical 17. That's not in simplest form because it's not proper to have a radical in your denominator. So we're going to rationalize it by multiplying. And you multiply by the radical in your denominator as a fraction with that same number on the top and the bottom. So I would take this and multiply by radical 17 over radical 17. And now I multiply across. So 1 times rad 17 is just 1 rad 17, or just rad 17, the one's not necessary. And then rad 17 times rad 17, use that shortcut, is the whole number 17. So that would be your final answer because you can't break down the square root of 17. Same thing on number 8, we have 1 over rad 7. It's not okay to have a radical in your denominator, so we're going to rationalize by multiplying by the radical on top and bottom. So 1 times rad 7 is just 1 rad 7 or rad 7, and then rad 7 times rad 7 is the whole number 7. And again, that can't be simplified, so you are done. So number 9, we have the square root of 5 over 17. So 5 over 17 can't be simplified, but it's not in proper form. So we're going to rewrite this as 2 smaller radicals. So this becomes rad 5 over rad 17. And you can have a radical in the top. You just can't have a radical in your denominator. So now we have to rationalize by multiplying through by the radical in your denominator. So times rad 17 over rad 17. Multiply your numerators together. So rad 5 times rad 17 is rad 85. And then rad 17 times rad 17 is the whole number 17. Double check, does 85 have any perfect square factors? If so, use your factor tree. But we're in luck, there are no perfect square factors, so that would be your final answer. All right, on to the next row. So we have 2 rad 11 over 3 rad 5. So the problem is the rad 5 in your denominator. And even though it's 3 rad 5 down below, to rationalize, all you need is the radical in your denominator. So we times by rad 5 over rad 5. You rationalize with the radical. And now we multiply, so the tops go together. So 2 times the silent one here is 2. And rad 11 times rad 5 is rad 55. Over down below, 3 times 1 is 3. And rad 5 times rad 5 is the whole number 5. Continue to simplify, so now we have 2 rad 55 over 15. 55 has no perfect square factors, and 2 over 15 can't be simplified, so you're done. All right, same thing on number 11, rad 3 over 3 rad 12. You only have to rationalize with your radical, so times rad 12 over rad 12. So rad 3 times rad 12 is rad 36. And then over 3 times the silent one here gives you 3, and rad 12 times rad 12 is the whole number 12. Now we simplify. The square root of 36 is the whole number 6, and 3 times 12 is 36. This fraction can continue to be simplified because you have the common factor of a 6, and 6 divided by 36 is simplified down to 1/6 for your final answer. All right, number 12, 2 over 3 rad 6. Again, it is not okay to have a radical in your denominator, so we rationalize with our radical. So times by rad 6 over rad 6. So 2 times rad 6 is 2 rad 6. Over down below, 3 times the silent 1 is 3, and rad 6 times rad 6 is the whole number 6. So this becomes 2 rad 6 over 3 times 6 is 18. But be careful, the numbers outside the radical, the 2 and the 18, 2 over 18 can be simplified. They each have the common factor of a 2. So 2 divided by 2 is 1, rad 6 over 18 divided by 2 is 9. So this is really radical 6 over 9. So this is radical 6, not the whole number 6. So now we cannot simplify any further. So where do you stop? All right, 3 more. So on our question number 13, we have 4 rad 7 over 8 rad 28. So again, we rationalize with our radical, so times rad 28 over rad 28. And if you wanted to simplify 4 over 8 first, you totally could do that. But I'm just going to stick with my routine because it's working and multiply the tops together. So 4 times the silent one here is 4. And then rad 7 times rad 28 gives you rad 196. Over down below, 8 times the silent 1 is 8, and then rad 28 times rad 28 is the whole number 8. And then 196 is a perfect square, so the square root of 196 is the whole number 14. So now we have 4 times 14 up top, over 8 times 28, which is 224. And 4 times 14 is 56, over 224. And then to simplify this, you could type in 56 divided by 224. You get a decimal, then press math, enter, enter, or recognize it's a common one, and you get 1/4. Always simplify as much as you possibly can. All right, on to number 14. Now we have variables under our radical, okay? But still you rationalize with the radical in your denominator. So times rad 10x over rad 10x. So up top, two radicals multiply together give you a radical, and 5 times 10 is 50, and x times x is x squared. And then over down below, 3 times the silent 1 is 3, and rad 10x times rad 10x is just the whole 10x. Now simplify if you can up top, and this time 50 has a perfect square factor. This breaks down to rad 25 times rad 2, and the square root of 25 is the whole number 5. So this becomes 5 rad 2, and then x squared, the square root of x squared is the whole letter x, because the silent 2 can go into x squared one time. And then over down below, we have 3 times 10x is 30x. Now we keep on simplifying, so the first thing that I see is that I can cross off the x's. They're a common factor on top and bottom. And then 5 over 30 can also be simplified. So if you divide 5 by 30, do math, enter, enter. That gives you 1 over 6 with the rad 2 up top. And the 1 is not necessary, so this becomes rad 2 over 6. And our last one, we have 3 rad 3x over the square root of 18x to the third. So again, we rationalize with our radical from our denominator. So times 18x to the third over radical 18x to the third. Multiply the outside numbers together. So 3 times your silent 1 is 3. And then your radicals. 3 times 18 is 54. And then x times x to the third is x to the fourth. And then over down below, radical 18x cubed times radical 18x cubed just gives you 18x cubed. 54, we know, has the perfect square factor of 9 and 6. So we can break this down to rad 9 times rad 6. And the square root of 9 is the whole number 3. So then we multiply our 3's together by the coefficient. So 3 times 3 gives you 9. And then we have the square root of x to the fourth is x squared. And then over down below, 18x to the third. Keep on simplifying. 9 over 18 gives you 1 over 2. And then if you have 2 x's up top and 3 x's on bottom, you can cross off those common x's, or 3 minus 2 is 1, and that 1x goes on the side of your bigger exponent. So 3 is bigger than 2, so the x goes down below. And we also can't forget about this rad 6 that I almost forgot about. So this should be 1 rad 6 over 2x. So this right here would be your final answer. Yeah, this rad 6 goes right here. My bad. If you guys have questions, please let me know. If not, go ahead and begin to work on your homework.